Good afternoon, all. Am I audible? Hello. Okay. So today we are going to see the remaining points from unit number 1. That is, we are going to do revision of these points. First point is equivalence of formulas. So when we can say that two formulas are equivalent, if we are getting same values for both the formulas, then we can say that is those two formulas are equivalent. So likewise, negation of negation P. This is equivalent to P. Why? Because here negation gets cancelled and you will get P. Likewise, P or P. This is equivalent to P. Why we have called these two formulas as equivalent? Because we are getting same value for both the formulas. So what is the definition for this equivalence? This statement formula A and B are equivalent provided that A biconditional B is tautology. So this is the condition for equivalence. If A and B, these are the two formulas, then we can say that A is equivalent to B if and only if A biconditional B is tautology. So how we can write this equivalence? So this is the symbol for equivalence and we can read this one as A is equivalent to B. This is an equivalence. So again, this equivalence is satisfying some properties. First property is symmetric property. So what is meaning of symmetric property? If A is equivalent to B, then B is equivalent to A. This is symmetric property. Second one is transitive property. That is, if A is equivalent to B and B is equivalent to C, then we can say that A is equivalent to C. So these are the two properties satisfied by equivalence relation. Equivalence, we can say uh, equivalence terminology. Now here in this question, they have said prove that P conditional Q, this is equivalent to negation P or Q. Already we have seen that this P conditional Q, this is same as negation P or Q. So now we have to prove how they come true. That is, these two formulas are equivalent. Now here in this formula, there are two variables P and Q. That's why again there will be 2 raised to 2, that is 4 possible combinations of truth values. Then we have to take this column as P conditional Q, then negation P or Q, and in the last column we have to prove its equivalence. So how we can prove it? We have to take biconditional between these two formulas, that is P conditional Q and negation P or Q. And if this biconditional comes true, then only we can say that these two formulas are equivalent. So check here, values of P, PTFF, values of Q, TF, TF, then value for P conditional Q. So what is the rule for this conditional? TF, then F, and for all other combinations it is remaining T only. Now check here, TF, F, TT, T, FT, T, FF, T. Only for this combination TF it is F. Now next column is negation P. So negation P means what? We have to apply negation on this column P. So T should be replaced by F and F should be replaced by T. So TTFF becomes FFTT, and that is written over here in negation P column. Next one is negation P or Q. So this is negation P, this is Q, and we have to take disjunction between these two columns. FF, then only F, and for all other combinations it is T. Now check here, TF, T, FF, F, TT, T, FT, T. And now finally we have to take biconditional between P conditional Q and negation P or Q. So what is the rule for biconditional? TFF, FTF. Now check here whether there is any combination which is TF or FT. No. So here all the values are T only. That's why last column is containing all the values T. That's why this is a, these are the equivalent formulas, because we proved that biconditional between these two formulas is a tautology. That's why these are equivalent formulas. Hello? Have you understood this example?
Yes, ma'am.
Okay.
Yes, ma'am.
So this is the example where we have proved this equivalence by truth table. Now sometimes they may ask you that prove this equivalence without constructing a truth table. At that time we have to use some formulas and we have to prove it. So likewise here they have given in the second example, show that P conditional, Q conditional are, this is equivalent to P conditional negation Q or R. This is equivalent to P and Q conditional R. So here we have to prove equivalence between these three formulas. So first of all we will consider these two formulas, first and second. Then we will think about third formula. Now check here. First formula is P conditional, Q conditional R. Okay. So again, this Q conditional R, we can write this one as negation Q or R. Just we saw that formula. And again, we can write this one as P conditional negation Q or R. So what we did here, just we replaced this Q conditional R by its equivalent formula, and that formula is negation Q or R. So now our formula becomes P conditional negation Q or R. Now check here, this is the second formula, that is P conditional negation Q or R. So here we proved equivalence between first and second formula. काय केलं समजलं का? फर्स्ट अँड सेकंड फॉर्म्युला कसं इक्विव्हॅलंट आहे? जस्ट वी रिप्लेस दिस Q conditional R by its equivalent formula, that is negation Q or R. So our formula becomes P conditional negation Q or R, and that is second formula. That's why these two formulas are equivalent. Now we have to prove that these two formulas are equivalent with third formula. So which one is the third formula? P and Q conditional R. Okay. Now we got that first and second formula, these are equivalent. So again we can convert this P conditional negation Q or R into and its equivalent formula, that is just we have to replace this conditional as negation P or negation Q or R. So here that formula we have written here. So again we can convert this one into another formula as negation P or negation Q. This is one bracket or R outside the bracket. Now again, if you observe, in these two terms negation is common. That's why we can take this negation outside. So negation of P and Q. So why we have written here and? Because if you apply this negation over this bracket, then you will get negation P or negation Q. So while taking this negation outside, this or should be replaced by and. So negation of P and Q or R. So again we can replace this one by using its equivalent formula as P and Q conditional R. So why we have written this? Because we know that P conditional Q, this is equivalent to negation P or Q. Now here likewise this we got formed as negation of P and Q or R. So we can convert this one into conditional as P and Q conditional R. And now check here, Our third formula is same as this one, P and Q conditional R. So here first we converted this first formula into second one, and again we converted second formula into third one. That's why all these three formulas are equivalent. So likewise also we can do the equivalence. Have we understood this example?
Yes, ma'am.
Okay. So likewise again they have given some examples. Sometimes you have to use truth table, and sometimes when they says that show that at that time you don't have to use truth table. You have to prove it by using formulas. Now next point is a duality law. So what is this duality? So we have seen that two formulas A and A star are called as duals of each other if either can be obtained from another one by replacing and by or by and. And if that formula is containing some special symbols like T or F, then its dual must be obtained by replacing T by F and F by T. So these are the some rules they have given to check duality of any formula. If A is the formula, then we can write its dual by A star. And how we can obtain it? So we have to replace and by and or by and. Again, if your formula is containing some special symbols like T or F, then T should be replaced by F and F should be replaced by T. Then only you will get its dual form. Now check here. Here in this question they have given write the duals of P or Q and R. Okay. So again its dual will be obtained by replacing or by and by or. So first of all we have to replace this or by and as P and Q, and this and should be replaced by or as or R. So dual of this first formula is P and Q or R. Likewise, the dual of second formula is P or Q, and now here P is given. So what we have to do about this P? P should be replaced by F and F should be replaced by P. So we have to replace this P by F. So its dual becomes P or Q and F. So that is written here. Now third one, negation of P or Q and P or negation of Q and negation S. So we can write its dual as negation of P and Q or P and negation of Q or negation S. Just we replaced here and by or by and. So in this way we can obtain dual of any formula. Do you have any doubt regarding duality law? Have you understood this?
Yes, ma'am.
Now, next point is tautological implications. So, before that, we have to see some terminologies. For any statement formula P conditional Q, the statement formula Q conditional P is called as its converse. Negation P conditional negation Q is called as its inverse, and negation Q, conditional negation P, is called as its contrapositive. So if your given formula is P conditional Q, then again we can define three different terminologies: converse, inverse and contrapositive. So for P conditional Q conditional P, this is converse. Negation P, conditional negation Q, this is inverse. And negation Q, conditional negation P, this is its contrapositive. Because this question they have asked for MCQ. Suppose if P conditional Q is given formula, then what is its contrapositive? At that time, you have to select its answer as negation Q, conditional negation P. Or they may ask you, like, if P conditional Q is the formula, then what is its converse? Or what is its inverse? Or what is its contrapositive? Likewise. So that's why you have to remember these terminologies. So again, P conditional Q, this is equivalent to negation Q, conditional negation P, that we have seen. This is its contrapositive form. Q conditional P, this is equivalent to negation P, conditional negation Q. Just we have altered the position of symbols. So what is meaning of this tautological implications or implies? A statement A is said to be tautologically implies a statement B if and only if A conditional B is a tautology. So if A conditional B is tautology, then only we can say that A logically implies to B. And how we can write that symbol for implication? This is the symbol for that implication. A implies B. So we can read this one as A implies B. So there are two different terminologies. One is for equivalence, another one is for implication. So how we can define the equivalence? If A and B, these are the two formulas, then A is equivalent to B if and only if A biconditional B is tautology, and A implies to B if and only if A conditional B is tautology. So these are two terms, those are very important. Again they have given here. A biconditional B states that A and B are equivalent, or A biconditional B is tautology. Similarly, A implies B states that A conditional B is tautology, or A tautologically implies to B. So just remember, for equivalence we have to take biconditional between those two formulas A and B, and we have to check whether it is tautology. And for implication we have to take conditional between A and B, and then we have to check whether it is tautology. So here they have given some formulas for implications. Now here we have to show how we can show that implications between any two formulas. So question is given as, show the following implications. P and Q implies P conditional Q. So first of all we are going to show this one by using truth table. So how we can prove these implications? We have to take conditional between these two formulas, and if that conditional is tautology, then only we can say that first formula implies second formula. So in this example, two variables are there, P and Q. So first two columns are for these two variables. Next one is for P and Q. Again next one is for P conditional Q. And now we have to take conditional between these two formulas. That is P and Q, conditional P conditional Q. Now check here. PTFF, TFTF for this P and Q. What is meaning of this and? That is for conjunction. If both the values are T, then only final value is T. and for all other combinations it is F only. So TT, T, and for rest of combinations it is F. Now P conditional Q. So T, F, F, and for rest of the combinations it is T only. That's why T, F, T, T. And now we have to take conditional between this third and fourth column. So again check whether there is any combination, that is TF, no, TT, T, FF, T, FT, T, FT, T. There is no any combination TF. That's why all the values in last column are T. That's why this is a tautology. So we can say that P and Q logically implies P conditional Q. In this way, we can prove it with the help of truth table. Have you understood this concept? Yes. Do you have any doubt regarding this
Yes, ma'am.
point? Okay. So likewise again, they have given some examples. So same strategy we have to apply. Just we have to check whether conditional between first and second formula is tautology. If it is tautology, then we can say that first formula logically implies to second one. Now, next concept is functionally complete set of connectives. So, what is meaning of this functionally complete set of connectives? So, whatever connectives we have seen till so far, like and, or, negation, conditional, biconditional. So, all these connectives are not necessary all the time. So, by using some minimum set of connectives, we can convert any formula into and its equivalent formula. That's why that set is called as functionally complete set of connectives. असे जे कनेक्टिव्ह आहेत ज्यांचा यूज करून आपण कुठलाही फॉर्म्युला दुसऱ्या फॉर्म्युलामध्ये इक्वलंट फॉर्म्युलामध्ये कन्वर्ट करू शकतो त्या सेटला आपण म्हणणार आहे फंक्शनली कंप्लीट सेट ऑफ कनेक्टिव्ह. सो व्हॉट आर दोज सेट्स? सो that is given here. So these are the some functionally complete set of connectives. That is, first set is and comma negation, and second one or comma negation. So these are the functionally complete set of connectives. We can't say either this negation and or these are functionally complete. So these are not functionally complete set of connectives. Only two connectives are there or two sets of connectives are there. Those are functionally complete. First set is and negation. Second one is or and negation. So many times they have asked MCQ based on this. Choose functionally complete set of connective from following set. And there may be options like and negation. This will be one set. Second will be set negation. Third will be set and last one will be set or. So at that time you have to choose this first option as set and negation. So only these two sets are functionally complete set of connectives. Why we have called this one as functionally complete? Because with the help of these two sets, we can convert any formula into and its equivalent formula. So how we can convert? So here they have given some examples. Question is given as write an equivalent formula for P and Q biconditional R or R biconditional P which does not contain the biconditional. So here from this example they have to remove biconditional. So how we can remove it? First we have to remove this first biconditional Q biconditional R. So we can replace this one by using its equivalent formula as Q conditional R and R conditional Q. So how this first term becomes P and Q conditional R and R conditional Q. So what we did here, just we replace Q by conditional R by Q conditional R and R conditional Q. So likewise, again we can replace this second biconditional using its equivalent formula using conditional as or R conditional P and P conditional R. Now check here, whatever formula we got, that does not contain any biconditional. So this is the correct form. So again we can replace this conditional, and that is given in next example. Write an equivalent formula for P and Q biconditional R which contains neither the biconditional nor conditional. Means what? They have to convert this formula into its equivalent formula which will not contain any biconditional as well as conditional. So how we can write it? First one is P and Q biconditional R. So first of all, we have to replace this biconditional by conditional. So we have to write the formula here. P and Q conditional R and R conditional Q. So in this first step, we have replaced this biconditional by conditional. Now in the next step, we have to replace this conditional as well. So how we can replace it? P and Q conditional R. So how we can write its equivalent formula? Negation Q or R. And for this R conditional Q, we can write equivalent formula as negation R or Q. Now check here. In this last step, whether we have written anywhere conditional or biconditional? No. So here we have converted any formula which is containing biconditional into an equivalent formula which will not contain any conditional as well as biconditional. That's why this say, that is negation or, and second one as negation and, these are called as functionally complete set of connectives, because any formula which is containing any conditional, biconditional, we can convert it into any another equivalent formula which will contain only negation or negation or and negation and. So this is concept of functionally complete set of connectives. Just you have to remember that only these two are functionally complete sets. First one is and negation, second one is or negation. So do you have any doubt regarding this point, functionally complete set of connectives? समझने का ही concept?
Yes, ma'am.
Okay. Now the next point is other connectives. So what are these other connectives? First one is XOR, second one is NAND, and third one is NOR. So these are the some other connectives. So what is this XOR? Let P and Q be any two formulas, then formula P XOR Q, in which connective XOR is called as exclusive OR, is true whenever either P or Q but not both is true. So that condition is given. So this XOR is given in this truth table. So what is the definition for this XOR? P, Q, these are the variables. then exclusive OR between these two variables can be written as P XOR Q. So when P and Q will have truth values identical, then only final value will be F. And for all other combinations, it is T. जर सेम व्हॅल्यूज असतील पी अँड क्यूच्या तर फायनल व्हॅल्यू तुमची एफ येणार आहे, अदरवाइज इट इज टी. सो चेक हियर pt means what? Both the variables are having identical values, that's why final value is f. tf, these are not identical values, that's why final value is t. ft, again these are not identical values, so final value is t. ff, these are identical values, that's why final value is f. So if p and q are having final value will be f, otherwise it is t. So again it is satisfying some properties like symmetric, associative and distributive. So that is given here. P XOR Q, this is equivalent to Q XOR P. This is symmetric property. Associative means what? If there are three variables P, Q, R, then if you change just brackets, then those two formulas will be equivalent. That is given by associative property. Next one is distributive. So P and Q XOR R. This is equivalent to P and Q XOR P and R. Just we have applied this AND operation over this bracket. And next two formulas are P XOR Q. This is equivalent to P and negation Q or negation P and Q. So how we have written this formula? What we said in this truth table of XOR, ह्याची फायनल व्हॅल्यू टी कधी येणार आहे जेव्हा हे सेम नसतील पी अँड क्यूच्या व्हॅल्यूज. So if you check this first t, what is value of p? It is t. So we can consider that variable in its original form, that is p. And q ची value काय f आहे. So we have to take its negation. So p and negation q. Or means what? At another time we will get value as t if value of p is f and value of q is t. So for this f, we have to take negation of p. So negation of p and value of q is t. So we have to consider it in original form, that is and q. That's why this formula has come. P XOR q. This is equivalent to p and negation q or negation p and q. And last one is P XOR Q. This is equivalent to negation of P by conditional Q. Now this we can prove with the help of truth table. Just you have to observe here. What is the truth table for P XOR Q? F P T F. And what is the truth table for P by conditional Q? Just tell me. What will be the value for P by conditional Q here? If P and Q, these are the variables, then what is the value for P by conditional Q? What is the rule for biconditional? कधी त्याची फायनल व्हॅल्यू एफ येते फर्स्ट. Yes. Are you there? Just tell me what is the value here for P by conditional Q. Hi, Naren. for P biconditional Q, TFF, FT, TFF, means what? It becomes TFFT. Now check here. If you apply that negation here on P XOR Q, you will get TFFT. Means what? This is equivalent to negation of P biconditional Q. That's why this fifth formula we have written. Okay, now just two connectives are remaining, that is NAND and NOR, that we will see next lecture. Do you have any doubt up till now? Hello?
No, ma'am.
Okay. You may present the roll number 1,
Yes, ma'am.
2, 3, 4,
Yes, ma'am.
5, 6, 7, 8, roll number 8, 9, 10, 11, yes, roll number 10, okay, 11,
Yes, ma'am.
12,
Present, ma'am.
13, 14, 15,
Present, ma'am.
16, 17, 18,
Yes, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Yes, ma'am.
22, 23,
Yes, ma'am.
24,
Yes, ma'am.
25,
Yes, ma'am.
26, 27,
Present, ma'am.
28, 29,
Yes, ma'am.
30,
Present, ma'am.
31, 32,
Present, ma'am.
33, 34, 35,
Present, ma'am.
36, 37,
Yes, ma'am.
38, 39, 40,
Present, ma'am.
41, 42, 43, 44, roll number 20, mute your mic, Rutuja, 44, 45, 46,
Yes, ma'am.
47, 48, 49,
Yes, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, 55, 56, 57,
Yes, ma'am.
58, 59, 60, 61,
Yes, ma'am.
62, 63,
Present, ma'am.
64,
Present, ma'am.
65, 66,
Present, ma'am.
67,
Present, ma'am.
68,
Yes, ma'am.
69, 70,
Ma'am, 9 is present.
9. Okay.
Ma'am, 3.
Yes. Or
Ma'am, 54 is present. ते चॅट बॉक्स मध्ये टाकला तिने.
हा.